We are looking at problem 12.5, which is looking at the expected rate of return on a corporate bond. So this is looking at bond valuation from the other end. So we're going to know what the present value is up front, what the price of the bond is, but we're going to figure out what the average rate of return, and this is also going to be the same thing as the average yield to a maturity interest rate in the market, and I'll show you why that is as we work through this problem. So if we look at our numbers up here, we can see that the face value of the bond is $1,000 and the coupon rate is 9%, but the price of the bond, or the present value of the bond, is $1,100. So that should tell us right away that the average rate of annual return on the investment is going to be less than 9%, because it's going to pay 9% on $1,000 over 10 years, but you actually paid more than the face value of the bond, so you're not going to get 9% on 1,100. You're going to get something less than 9% on that. Okay, so let's just prove that out. So let's just put in our numbers here. 1,000. Coupon rate is 9. Whoops, not 909. Let me go back. Okay. Years to maturity is 10. And the price of the bond is 1,100. So we can see we can see that the interest the bond is actually going to pay, because we're actually thinking about this two ways. One is you're paying this 7.54% on the 1,100, not on the 1,000. You're getting 9%. You would get 9% if we plug in 1,000 right here. If that's what the present value would be, then you would get the exact same as the coupon rate. But since we're paying more, then the actual interest we're getting is going to be less. Now, the other way we can see this is if we go back to problem 1 and use this 7.54 as our as the yield to a maturity for similar bonds in the market. If we say this is our opportunity cost, so if we put in our $1,000 for the face value of the bond, coupon rate was 9, years to maturity was 10, and then if we use that 7.54 right here that we computed just now, we can see that the present value of the bond is 1,100. So this sort of proves out that when the required rate in the market is lower than the bond is actually the coupon rate, or the interest rate the bond is actually paying, then the price of the bond is going to be higher than the face value of the bond. And then what we're seeing in problem 12.5 is that when the price of the bond is higher than the face value of the bond, then the actual interest rate you're getting paid on your investment of 1,100 is slightly lower than the coupon rate on the 1,000, because you're getting paid, once again, I'm just over explaining this probably, but you're getting paid 9% on 1,000. You're getting paid 7.54 because your payments are going to be, every year 9% of the face value. So those payments would actually be 7.54% of the higher price of the bond. Okay, so that's problem 12.5.